This is Jose Ramirez, and today we're going to talk about logic gates using AND logic, OR logic, and NOT logic. Just like this. For this project, we're going to need a multimeter, breadboard, 9-volt battery, a Arduino power supply, 2 NPN transistors, an LED red light, 1 kilo ohm resistor, and a lot of jumper cable. Let's begin by checking our resistance so we can make sure we have the correct one. We want to make sure we have the right resistance. 0.992. The AND gate goes like this. Once we have the power going in here, passing through the 1 kilo ohm resistance, it basically stays here until we use the first switch. When the first switch is on, then the power passes through the emitter into the second transistor. Unless the second transistor has the switch on, then it's gonna pass through here and turn the light on. The only condition about the AND gate is that both transistors needs to be in on position in order to turn the light on. Otherwise, if one of them is off, then the light will turn off. In our pegboard, we want to identify the positive and the negative side. We connect our 1 kilo ohm resistance from the positive into number 20. Then we get our NPN transistor like this, and then we connect the second one. Now that we have both transistors in place, we're gonna make sure we connect the positive side of the LED into the emitter of the second transistor and the negative into ground. With the LED in place, then we're going to use a cable to jump the first emitter into the collector from both transistors. Then we're going to connect our power source with our 9-volt battery and identify the ground and the 5-volt. We're going to connect the 5-volt with a red cable to the positive and the ground with the green cable to negative. As you can see, the light is not turning on. Now we're going to use 2 red cables as switches. We're going to connect the first collector to the base, and we have the first switch on. Then we do the same on the second collector to the base, and the light should come on. Now we have our AND gate. The second condition is the OR gate. And this is how it works. When the 5 volts is passing through here, through the 1 kilo ohm resistance, then if any of the switches is on, then the LED light is gonna come on. If only one is on, the light will come on. Or if both switches are on, the light will stay on. But at least one must to be on in order for the LED light to stay on. By using the same configuration as the AND gate, for our OR gate, we're gonna have to jump the 2 collectors together and the emitters. We're going to use 2 red cables as switches. Now we have power. If any of the 2 switches come on, the light should come on as well. This is the OR gate. Now we have the NOT gate, and this is how it works. When you have your power source passing through the 1 kilo ohm resistance, you have your LED light on at all the times. But when the switch is on, passing through the NPN transistor, then the power will flow through here, bypassing the LED light, causing it to go off. Lastly, for the NOT gate or inverter, we're going to use a different configuration. We're going to get rid of 1 transistor. Now we jump the collector to the positive side of the LED, and the emitter to ground. Now let's check it out. The light is gonna stay on at all times unless the switch is applied in between the collector and the base. And this is how logic gates work.